Wow. That's a lot of variables. Oh man, are those fractions? Oh man, are we subtracting these fractions? Are there variables in these fractions? Are these rational expressions? Is that what you're saying to yourself right now? That's what I'm saying to myself. Whew. It's a tough one right here. It's a tough one right here, but that's a good thing. That's a good thing because now we know we can handle this. And my goal is to teach you how to handle this because I look at this and I'm not scared about it. I'm not worried about anything. That's the confidence I have. You see, if you had that same confidence, you wouldn't be worried about this either. And I'm going to show you why. Watch this. We're just subtracting fractions. That's all we're doing here. Look, a while back, at some point, one of your teachers said something to the effect that 6 over 7 minus 1 over 7 is equal to 6 minus 1 over 7, which is 5 over 7. And this we got. And you said, oh, I can do this. And you learn, you look at this pattern, you said, you know, the denominators don't change. When we're subtracting fractions, the denominators don't change. Well, they still don't change. So you got that. Take your first step on these problems, do it one step at a time. And the first step is to acknowledge and embrace the fact that the denominator doesn't change. All right. Now look at what happened with the numerator. It was 6 over 7 minus 1 over 7 is 6 minus 1 over 7. It's that numerator minus that numerator set over that denominator. So just do that. And just set the problem up. Don't try to do the whole problem in one step. That's a theme I keep coming back to. Simply write it like I did. It's this minus that. So we've got 10x minus 7 minus 8x minus 13. One step at a time. You're going to be so much more effective because you're not going to be worried about things that aren't in the step that you are currently doing. Like right now, you look at this, and you might say, oh my gosh, what am I going to do? Don't think like that. Think, you know what? I just need to combine like terms here at the top. I want to simplify this thing on the top. And if I'm dealing with the top, known as the numerator, then I'm just simply going to rewrite the denominator. Because I'm not currently dealing with the denominator, so I'm not going to worry about it. I'm just going to rewrite it and focus on what I do need to be concerned with. Now, there's technically a positive 1 out there that we don't write. And if you distribute a positive 1, nothing changes. So, the 10x minus 7 remains the same. We want to subtract these values, but they're inside parentheses. So, you distribute what amounts to a negative 1, and all the signs change. So negative times a positive is negative, and negative times a negative is positive. All right. Well, let's just keep going. The top part is still not simplified. The numerator is still not simplified. So I'm yet to be concerned with the denominator. I'm just going to keep rewriting it. All right. Let's combine like terms. I got a 10x minus an 8x gives me 2x. And negative 7 plus 13 gives me plus 6. All right. Now my numerator is simplified. I've combined like terms. Now I got to simplify this whole rational expression. And we had 2 steps for simplifying a rational expression. Let me rewrite them. Step 1. Factor things. And step 2. Cancel stuff. Factor things and cancel stuff. Now this is just a pointer. It's meant to be general. You still, of course, have to know how to factor and how to cancel, but this is just a signpost saying, yo, come this direction. Start factoring things. We know how to factor these. Let's just start at the numerator. You confused about where to start? I'll give you. Start at the top. Start at the numerator. You want to start at the denominator? Fine. This is a binomial. You have 1, 2 terms. So when you got 2 terms, it's not a difference of squares because it's not a difference. So we find a greatest common factor. Okay, so for this one, we are going to find a GCF. In this case, it is the number 2. So you take out the 2, and you got x plus 3. On to the denominator. 1, 2, 3 terms. That's money in the bank now. 3 terms. Every time 3 terms, our process was the X box. Okay, that's how we've been doing these. Where the X marks the spot style, where you put 21 on top, you put 10 on the bottom, and you look for 2 numbers that multiply to give you 21 and add to give you 10. In this case, 3 and 7. So over here, that becomes x plus 3 and x plus 7. All right, the top, the bottom, they're totally factored, so we have factored things. Lastly, let us cancel some stuff. We are multiplying by x plus 3 and dividing by x plus 3, so these are going to cancel. And we are going to end up with 2 over x plus 7. Put a square around that, because that, my friends, is the answer. It's beautiful. It's beautiful. It looks very complex, but as long as you take it step by step, you can make it much more easier on yourself. Okay? So let me get you one more example for this video. One thing you might want to do is just rewind the video and see if you can't do that problem now without watching it. I'm going to leave the factor things, cancel stuff, because we're still going to have to do that. That's not going anywhere when it comes to rational expressions. Okay, so here's the second one, the last one for this video. We got 5x over x squared minus 5x plus 6 minus x plus 12 over x squared minus 5x plus 6. Pause this video right now and give this problem your best effort. Hit pause now. All right, let's do this thing. First off, I hope you tried this problem. I hope you tried it. Because you got to try. You can't just wait always for the answer. Figure out what you don't know, and the only way to figure out what you don't know is to really apply yourself. Okay, so I hope you tried this problem. And when you're trying this problem, I hope you looked at an example like the one I gave before, which was something like, what, 6 over 7 minus 1 over 7 is 6 minus 1 over 7. Apply this to that problem. Tell yourself the denominator doesn't change. So go get that part first. First, rewrite it with the same denominator. And feel good about that. Tell yourself I'm not going to skip steps today. 6 minus 1. It's just write 6 minus 1. So you do that. Put this denominator, or this numerator, rather, minus that one. One step at a time. One step at a time. It's going to be easy money. Now, we need to still simplify the numerator. Now, the denominator don't change. So rewrite it, because right now we're still trying to combine like terms up here. So while we're working on the numerator, let's not worry about the denominator. Let's just keep it the way it is. In order to simplify this, you've got to get rid of these parentheses by really recognizing that that is in fact a negative 1. And when you distribute a negative 1, what happens is the signs change. So negative times a positive is negative. Negative times a positive is negative. All right, we almost there. Let's combine some like terms. 5x minus x. We have 4x minus 12 over x squared minus 5x plus 6. All right, we've combined all our like terms. We got 2 rational expressions, which is now just 1 rational expression. So the only thing left, ta-da, is to simplify. is to factor things and cancel stuff. Yo, we keep coming back to this. This is going to be an old friend for you. Oh yeah, factor things. I got this. I got this. And you got this. Okay, we got to find the GCF on top. And on the bottom, we're going to do the X marks the spot again. Because it's a trinomial. 1, 2, 3 terms. Alright? So, in here, the greatest common factor between 4 and 12 is 4. If you take out a 4, you still have the X minus 3. On the bottom, look, we need two numbers. One that multiply to give me 6 and add to give me negative 5. What is that? And maybe you can't figure that out, but that's all good. If you can't figure that out, here's what I need to see on your paper. I need to see you searching for factors of 6, like 6 times 1 and 3 times 2, and asking yourself, which one of these, if I add or subtract, could possibly get me to the number 5 or negative 5? Well, in this case, they're both probably going to get you there, so you're going to have to really think about which one this is. But if in order for you multiply to get a positive, either they're both positive or they're both negative. So in this case, 3 and 2, if they're both negative, they add to negative 5, they multiply to positive 6. Okay, so we have x minus 3, x minus 2. Things have now been factored. Yo, let's cancel some stuff. This is it. This is the fun part here. We just look for the things that are the same. Oh, boom, I see you, x minus 3. You get that? 4 over x minus 2. That's how we do. This is simplifying rational expressions. These denominators are the same. They have common denominators. So when that happens, simply take this numerator and subtract that one. You need to combine like terms by distributing. Or you distribute, then combine like terms. Then you factor things, then you cancel stuff, then you take your marker, flip it, do a little behind the back action, and say, have a good day. I encourage you to do more of these problems. And let's learn something, baby. Let's do it.